So alkenes are unsaturated hydrocarbons. Okay, we did the naming in detail, which basically means that they have a double bond. Okay, anything that has a double bond is unsaturated, and this is पहले से हमने naming की हुई है in a lot more detail. So this is what an alkene looks like. This is propene. Now, the very first thing about alkenes is that you should know what type of hybridization happens when an alkene is formed. So the carbon atoms over here are in a double bond are sp2 hybridized. What that basically means is that sp2 hybridization happens when carbon is bonded to just 3 atoms. Hania, can you hear me?
Yes, sir.
So it's bonded to 3 atoms, just 3 atoms, and this is what happens. I'll just briefly go over hybridization. Carbon's electronic configuration, the outermost shell has 4 electrons. It's got 4 electrons, 2px1, 2py1, and there is 2pz1. But in sp2 hybridization, what happens is that the carbon atom is only bonded to 3 atoms. So it's bonded to an atom on the right side. It's bonded to an atom on the left side. So this wedge-shaped bond shows that the bond is going out of the page. Okay, just like a fan. And it's bonded to an atom. All atoms are bonded at an angle of 120 degrees. So there's atom number 1. There's an atom on this side, and there is an atom on this side. So the carbon atom in the center is bonded to, this carbon atom over here is bonded to 3 atoms. And the shape, so basically what's happening is that 3 of the electrons of carbon in its outer shell, they get pulled in different direction. One gets pulled by one of the atoms, the other one gets pulled by another atom, and the third one gets attracted to a third atom. Okay, so they are just like, if you look at this carbon atom over here, the one that I'm trying to circle at the moment, okay, this one, then that carbon atom is only at the moment just bonded to 3 atoms. So 3 of its electrons get pulled in different directions. What happens to the 4th electron? There's a 4th electron of carbon, and initially nothing happens to it. No atom, because there is no 4th atom. So the 4th electron is as it is. Nothing happens to it. So that's your p orbital. That remains unchanged. So you've got one p orbital, it's got 1 electron in it. The other ones, they all change their shape. So you start calling them with different names. You start calling them sp2 hybrid orbitals, because the shape has changed. Remember, the s is a spherical, an electron in the s occupies a spherical orbital. But if the s orbital, the electron in that, gets pulled by one of the atoms, then the shape changes. You start calling it, you start giving them different names. You start calling them sp2 hybrid orbitals. And each of the sp2 hybrid orbital has 1 electron. So the only reason you change the name of the orbitals is because the shape has changed. One of the atoms is getting pulled in this direction, one of them is getting pulled in this direction, one of the electrons is getting pulled in this direction, and the 4th electron remains unchanged. So that's still the p orbital. TK, is this point clear? Hania, is this clear? Zari?
Yes, sir.
No.
Yes.
So just a moment. So this is So this is what carbon would look like when it's forming a double bond. So I'm going to draw a molecule of ethene, and carbon would look exactly like this. So I've got ethene is like this. Ethene has double bonds, and each carbon atom is bonded to 2 hydrogen atoms. So here's an atom of ethene, and the carbon atom is sp2 hybridized. So it's bonded to 3 atoms, 1 bond, second electron bonds over here, third electron. So that's your fan. And the 4th electron remains unchanged. So the 4th electron is kind of not doing anything at the moment. Just a second. So the 4th electron drawing the 4th, all the 3. Anyway, so both carbon atoms are identical. They're both sp2 hybridized. You've got 1 electron getting pulled in this direction, 1 getting pulled in this direction, 1 getting pulled in this direction. The 4th electron remains unchanged. The other carbon atom is exactly the same, and the electrons are getting distributed in 3 different directions, and the 4th electron remains unchanged. So the 4th electron ends up forming a pi bond, and that's where the double bond. That's how the double bond is formed. They start overlapping. They start pulling each other's electron, and the 4th orbital that was initially not doing anything, it eventually ends up forming a pi bond. So what you need to remember is that the pi bond is formed when a p orbital overlaps with another p orbital of the carbon atom. So it's a p and p overlap. The sigma bonds that are formed over here are formed by the sp2 hybrid orbitals, the ones that had initially changed their shapes. Okay, so is this clear? The shape of a double bond, right? Clear, yes or no?
Yes.
So now the next thing is that we're going to talk about. We're going to talk about quickly the physical properties of alkenes, and the physical properties are kind of the same as alkanes. Okay, so just very quickly, we're going to talk about the physical properties of alkenes. So they're exactly the same or similar to alkanes. Not much different. Number one, they've got van der Waals forces. They've got low melting and boiling points. And why do they have low melting and boiling points? Because they have van der Waals forces, which are weak intermolecular forces. They're non-polar molecules, and they increase with size. The bigger the molecule, the more van der Waals forces it's going to have. Number two, they're not going to be, they're not soluble in water. Why are they not soluble? Because they can't form hydrogen bonds. Water molecules, they form hydrogen bonds. They're incapable of attracting water molecules, so they can't form hydrogen bonds. But they are soluble in non-polar solvents like oil. So examples are oil, CCl4. So you've got plenty of non-polar solvents. So these are some of the physical properties of alkanes. We can add a third one, which is that they are neutral compounds, so they're not acidic or basic, etc. They don't conduct electricity. They don't get ionized. So no electric conduction as well. As anyway, so those are physical properties. What we're going to talk about now is we're going to talk about the reactions of alkenes. And first, we're going to write a rough summary of all the reactions of alkenes. And then we're going to talk about the mechanisms of those reactions. So I'm going to draw an alkene over here, and that alkene is propene.
Sir,
Yes.
could you just scroll up a second so I can screenshot it because I didn't finish writing?
Okay.
Thank you, I did it.
Okay. So this one, most of the reactions are like Wolf's reactions. We're going to just quickly go over them, and then we're going to talk about them in detail. So the first one is bromination. So what you do in bromination is that you add Br2, which is either aqueous or in an inert solvent. So it's either aqueous or inert solvent, which is most of the time it's CCl4. So that's the first one, bromination. What happens in bromination is you redraw the molecule, everything kind of remains the same. Just 1 second. So redraw the entire molecule, everything kind of remains the same except for the double bond part. The double bond goes away and it turns into a single bond. And the Br atoms, they get attached to both carbon atoms. So that's what's happening in bromination. We can rub this off. So that is what's happening in bromination. Now, bromination, if it's aqueous, you might also get OH ions, but only if it's aqueous. So if the solvent is water, an additional thing might be produced. A second. So if the solvent is water, you might get an OH ion as well, but only if the solvent is used is water. So there might be some OH ions that would be floating around, and they might get attached to the alkene. So you've got these things. The importance of this reaction is that it's a test for unsaturation. If you want to figure out a molecule has double bonds, you react it with bromine. So red, brown, or sometimes referred to as orange bromine, it gets decolorized. So that's the importance of this reaction, which is bromination. Okay, this is referred to as a bromination or called a bromination reaction. So we can write that down as well. Now, the other thing about this reaction is that so most of these reactions are kind of very similar. So let's move to the next one, which is hydration. So this one is hydration. In hydration, it's a reaction with water. So you add water in the form of steam because the temperature that's used is very high. It's 300 degrees centigrade. And it's 60 atmospheres. That's the pressure that's used. And you use phosphoric acid catalyst or any acid as a catalyst, but the most suitable one is phosphoric acid. Now in hydration, something similar happens. You have this molecule and the molecule kind of remains the same, except for the double bond part. Things get added to the double bond. So you have kind of the same molecule, it's CH3. Instead of the double bond, you now have just a single bond. And an H and an OH will get attached. And you can get two different products. One of the ones that I've drawn over here, the other one is what you could also have is that the H and OH can get attached the other way around. So it could possibly, so the OH and H, they can be on different carbon atoms. So the OH could be on the center one and the H could be on the middle one. So you can have two different products. We're going to talk about major and minor products in a bit, but I'll just write that the probability of actually getting this product is a lot higher. That's known as a major product. This one is actually the major product, sorry. So the bottom one is our major product. That's the one that has a higher probability. The top one is the minor product. And we're going to discuss why that happens. But once we're done with this. Okay, so you've got hydration. You've studied this in O levels as well. There's another one which is hydrogenation. So what happens in hydrogenation? You add hydrogen to it. H2 gas gets added and the temperature is around 150 to 200 degrees centigrade, and there's a nickel catalyst involved as well. Now, this is a type of reduction reaction where something exactly the same as before happens. The double bond, things get added to the double bond, but this time the thing that gets added are more hydrogen atoms. So this is the reaction with H. So more hydrogen atoms get added to it. The significance of this reaction is that you use it for formation of margarine. From unsaturated vegetable oils. So what they industrially do is that butter is really expensive. So what they do is they make this artificial form of butter, which is that you take unsaturated vegetable oils, which are liquid, like canola or sunflower or olive oil, and they add hydrogens to it. So adding hydrogen increases the size of the molecule. Now, if the size of the molecule increases, there's going to be more van der Waals forces. And if there are more van der Waals forces, what's going to happen is they're going to have higher melting and boiling points, which is why margarine is a solid at room temperature. So it's the same vegetable oil, except that by the addition of hydrogen, the size of the molecule slightly increases. So you get a bigger molecule, and it's going to have more van der Waals forces, which is why it's going to be a solid instead of being a liquid, like vegetable oil usually is liquid. So margarine is just a solidified form of vegetable oil. And then there's a third reaction, which is kind of similar. This third reaction is with hydrogen halides. So that is with HCl, HBr, or HI. No special conditions are needed for that, and exactly the same thing happens. The double bond, things will get added to the double bond. H, for example, H and Cl will get added. And again, there are going to be two versions for this. The second version would be that the H and Cl get added to. So they get added to different atoms. And this one is going to be called your major product. And we're going to discuss why it's the major product. So the thing is, every time what's going on is that things get added to the double bond. You've got a double bond. Whenever you see a double bond, all these four reactions are possible. You can have bromination, you can have hydration, you can add hydrogen to it, or you can add HCl or HBr or HI to it. And these sets of reactions are known as electrophilic addition. Okay, I'm going to talk about that just a while. I said this one over here, the thing is that this one has a different mechanism, except for this one. And we're going to study all the mechanisms. So it's got a different mechanism. This is the example of a heterogeneous catalyst. Okay, so we're going to talk about this later on. I mean, first we're going to do the mechanism of electrophilic addition for these three, and this one is called an addition reaction. I mean, it's called an addition reaction, except that it has a different mechanism. So we can start by discussing. We have to discuss two things now. One is the mechanism of the reaction of electrophilic addition, and the other one is that we have to discuss the major and minor products. Why do you get major and minor products? So first thing, mechanism of electrophilic addition. So what happens is, if I draw an alkene or ethene molecule, this one over here, it's got this huge pi-electron cloud. And pi-electron clouds, obviously, they've got electrons in them. And if they've got electrons in them, they're going to attract electrophiles. Electrophiles are substances or species that are attracted to electrons. So for example, let's talk about a bromine molecule. What would happen is that the bromine molecule is going to, I mean, it'll be flying around, it will come close to it. And when it gets close to this, because of the electron cloud, the electrons in the bromine bond, they're going to get repelled. They'll be repelled further away because of the large negative charge over here. And the bromine molecule will get polarized. The top one would become positive and the bottom one would become partial negative, because all the electrons in the bromine molecule are getting pushed downwards because of repulsion from the electron cloud. All the electrons in bromine are getting pushed downwards. So the bottom one becomes So the bottom one gets a partial negative charge. Now, if it gets a partial negative charge, so the first step is the Br2 molecule gets polarized.
So how does it gain a negative charge?
See, there are lots of electrons over here in this double bond, right? Hania, is this clear? So what's happening?
Yeah.
What's happening to the electrons in this molecule? They're going to get repelled, right? Because of the electrons over here. So they'll all be pushed downwards. So what would happen is that the electrons over here were evenly distributed, but now they're being pushed downwards. And eventually what would happen is that the bond will break. The electrons in the bond will, and this is known as heterolytic fission, electrons in the bond are going to get pushed downwards. And this is what's going to happen in the next step. So let me draw the next step. That you have this ethene molecule with the so this is what's going to happen. The Br over here is going to take both electrons, it's going to get repelled, right? Okay, so the Br is going to take both electrons, that's going to get repelled, right? So this Br will get a -1 charge. And the top Br is going to eventually get a positive charge. So the bond is going to break. The molecule is going to completely get polarized and the bond will break. What this Br positive will do is it's going to try and attract, it's going to attack. It's a positively charged molecule, ion now. So it's going to try and attract or gain those electrons in the double bond. So all the electrons in the double bond are going to be gained or attracted to Br positive. So all these electrons over here, they'll all get dragged towards this Br, which is positive, and a bond will form. The carbon will eventually form a bond with this Br, which is positive, and it's no longer going to remain positive because it's going to attract electrons from the, so all the pi electron cloud over here, they're going to get attracted to the Br, which was positive previously. Is that clear? Hania, is this clear?
Yes, sir.
And the other carbon atom would get a positive charge. Why? Because the electrons that were over here forming a pi bond had electrons belonging to this carbon atom as well. So Br positive stole all those electrons, took it and joined with them. And so this carbon over here lost its pi electron cloud. So this carbon over here lost its pi electron cloud to Br because Br took it. And which is why that's now positively charged. So in the next step, a carbocation intermediate is formed. And now you've got a positive charge and you had a Br -1 ion, which had broken off initially. So this would come in and this would then get attracted to the positive carbon over here. So this one. Is this clear? What's going on here? So I'm just going to repeat this quickly that you had a double bond. And the double bond pi electron cloud, there were electrons buzzing around over here, and the electrons over here, they got repelled. That broke the molecule over here into two parts. One became a positive ion, the other one became a negative ion. The positive ion went and stole the entire electron cloud over here and attracted it and bonded with it, taking away the electron cloud from this carbon atom as well, which is why that carbon atom became a cation. It became positively charged. And in the next step, the Br minus one that had broken off is going to come in and it's going to join with it. Is this clear? The whole entire mechanism? Yes or no? Is this clear?
Yes, sir.
Hani, is this clear? Faiz?
Yes, sir.
Yes.
Achha, so what we're going to do is we're going to draw the mechanism the way they expect you to draw in the exam. So the mechanism is, I mean, you don't have to draw the whole entire thing in 3-dimensional. So this is what is basically happening, and you have to be very specific with your curly arrows and with your charges as well. If they ask you to, and they very often ask you to draw the mechanism, so you have to be very, very specific. So you're going to show the Br bond. This carbon becomes positively charged. This carbon gets a partial negative charge. The positive bromine attracts electrons from the pi electron cloud. And in the next step, the positive bromine is going to bond with the carbon, and the double bond electrons would be stolen by this positive bromine. So this carbon will get a positive charge now, and Br minus one with its lone pairs now, with its extra electrons which it got, it's going to come in and join with this carbon atom. And as a result, both carbons will now have one bromine each. And that's your addition reaction now. Okay, that's your entire. So everything has to be very specific. When you draw this mechanism, everything has to be very, very specific. And you have to be careful in drawing the curly arrows, the positive charges, the negative charges, the Br minus one that is formed, the carbocation that's formed over here. So you have to be very specific with this. This is known as a carbocation intermediate. So that's known as a carbocation intermediate, and which basically means that this carbocation is actually formed in the reaction. It's a two-step reaction. This is step number one. And this is step number two. Is this clear?
Sir, could you repeat how the carbocation is formed?
Is formed?
Yes.
I mean, this is what happened, right? Okay. I mean, if I get rid of this. अच्छा, initially ये भी नहीं है, ठीक है? अच्छा, anyways, you had a double bond, right? You had electrons overlapping above and below, right? And this Br became positively charged. You had a positive bromine which got polarized, right? So the positive bromine would attract all the electrons in the double bond over here. Ye clear? Alicia, is this clear?
Yes, this part is clear.
So the electrons in the double bond, they get attracted to the positive bromine, which was over here, right? So who did it steal the electrons from? This carbon, right? Because the double bond, I mean, half of the electrons belong to this carbon atom. So this carbon atom will get a positive charge because the Br over here took its electrons. Is that clear?
Oh, yes, it's clear. Thank you.
ठीक है, इसके ऊपर charge नहीं होगा क्योंकि it still has, the electrons are still with it. ठीक है? I mean, the Br is still bonding to the same carbon atom, except, I mean, the carbon, initially was bonding to this carbon atom, but now, I mean, forming the double bond with this carbon atom, but now it's bonded to this bromine. So nothing happened to this carbon atom, but this carbon atom lost its electrons. So this is why the carbon became a carbocation because bromine took its electrons. Hani, is this clear? Zari?
Yes, sir.
So the other mechanisms are kind of similar. Like if you want to do it for, let's say HCl, it's going to be exactly identical. I mean, you're going to draw the same exact thing, except just replace bromine with HCl. And you're going to do another change, and that is, remember, if it's HCl, then the molecule is already polarized. Like you have an HCl molecule. Then remember this, that the H is the positive one. I mean, HCl was polarized from the very beginning. The H was positive, so the positive H is going to get attracted to the double bond first. So the atom that's going to bond with the double bond first is going to be H, followed by Cl, which would be -1. So the first atom to get attached to the double bond is going to be H, followed by Cl. Right? Is this clear?
Yes, sir.
And the same with water. With water, you're going to have H and OH ions, which would be exactly the same. So that's the mechanism. You have to remember this mechanism by heart, and every detail. TK will be asked. It's going to be a 3-4 mark question, and you should know every detail. If it's HCl, make sure you know that it's always the H that comes and attacks. The H is the one that's acting as an electrophile. It's the one that's attracted to the electrons in the double bond. And the same goes for water as well. I mean, I can just, I mean, there are two types of mechanisms for water, but they're both identical, exactly the same. I can just, instead of drawing this, so just the simplest, I mean, that's the one with HBr, just a second. Or maybe I'll just draw it. Just hold on a second. So the last one with water, that would be kind of the same, except over here, I'm going to draw OH. So there's going to be O and H. And over here, you'll have OH -1. So what would happen is that the bond of water, one of the H will get attracted, which would be positive anyways, will be attracted to the double bond, and the electrons would be repelled. So it would eventually become OH -1. That will break off. In the next step, the OH -1 would come in and would join with the carbocation that's formed. So that's it. So it's kind of, I mean, this mechanism usually doesn't, they usually don't ask you about this one. They usually normally just ask you about this one. TK. So here we still have to discuss major and minor products. We'll do that in the next task then. TK. So okay, everyone.
Okay, Allah Hafiz. Thank you.
Take care. Allah Hafiz.